Hello everyone, in this video we are just going to demonstrate and implement timer periodic interrupts in Raspberry Pi Pico. Let's get started. I'm just going to open the Tony IDE, which is the integrated development environment which we are going to use for developing our MicroPython scripts for Raspberry Pi Pico. And here just click on this particular icon or Ctrl N in your keyboard for creating a new file required for the project. And now you just want to save this file. Ctrl S or file save this computer and move to the folder where you want the project files to be stored. I'm just storing it as timer and it will be stored in the .py format automatically, whether you are giving this extension or you are not giving this extension. This will be automatically saved in the .py format. And as the first and foremost thing, we just want to import mission library, and from mission library I'm just going to import timer. So these two are the libraries that I'm going to import, or these two are the modules that I'm going to import. I'm just going to import the mission module and I'm just going to import the timer module from the mission module. And the next step is I'm just going to configure an GPIO pin as output for connecting an LED for demonstrating the timer periodic interrupt. Let's take the pin number here to be 16. So I'm just going to configure the 16th GPIO pin of the Raspberry Pi Pico as out pin or the output pin. So I'm not going to explain about this particular line right over here, since we have been writing this particular line from the first ever lecture of LED blink. So this will configure the GPIO 16th pin of Raspberry Pi Pico as output pin, and you can access or write the values to those output pin with the help of the variable LED right over here. So we are just declaring and defining a variable called LED, and which will store the configuration of GPIO 16 as output. So using this particular LED variable, you will be able to manipulate the state of digital output pin 16. So this is what this line means. And as the next step, I'm just going to initialize the timer. For that, I'm just going to declare and define another new variable. Let's take it to be tim, and I'm just going to call the method timer with the capital T. Just remember, this particular timer method will have capital T. And the first parameter for this particular method is period. So period defines the period at which the interrupt event must occur. So here I'm just giving it as 1000, which means 1000 milliseconds. And second parameter is the mode at which the timer must run. So here I'm just going to give it as periodic mode. So you cannot directly write it as periodic. Instead, you just want to write like mission.timer.periodic. And the third parameter is the callback function that you want to create. So here I'm just giving the name as timer_callback. So you just want to define this particular callback function in your program. So here I'm just going to define that particular callback with the parameter timer, and inside the callback I'm just going to toggle the state of LED defined right over here. That is the toggle the state of GPIO 16 of Raspberry Pi Pico right over here. So this is the only thing that I'm going to do right over here in this callback function. And here in this line you can see the timer method is initialized with the period of 1000 millisecond and in the mode of periodic intervals with the callback function timer_callback. Here you can give whatever name you want for your callback function, but I have given it as timer underscore callback, but maintain the same name right over here. You just want to define this particular callback function in your Python script. That is the thing. So what will happen here is, just consider this is the Raspberry Pi Pico processor, and this is the interrupt controller in the Raspberry Pi Pico. So as soon as the program starts, the processor or the timer is initialized in this particular line number 10, and this timer will start counting from 0, 1, 2, 3, etc. So it goes on like this, and when it reaches the threshold value of 1000 millisecond, this particular interrupt controller is initialized with this particular timer interrupt, so that this interrupt controller will interrupt the processor with the timer event. So this timer event is generated via the timer interrupt, and it will interrupt the processor, and whenever the interruption happens, this function right over here will be executed once, and after executing, the timer will be rolling back to the initial value, and after that the same process continues, and again the timer starts counting from 0 and it goes on till 1000 millisecond, and again the interrupt controller will be triggered with the timer interrupt when the timer period value matches with the actual counter value inside the processor, and the timer interrupt will be interrupting the processor, and again the same callback will be executed. So this is the basic functionality of timer periodic interrupts in any processor, and let's demonstrate this in our Raspberry Pi Pico development board, Raspberry Pi Pico W development board. I am just saving this, and I have already connected my Raspberry Pi Pico development board to my PC through micro USB cable. Before executing this, let me just explain to you the schematic diagram that I have built in my breadboard. It is very simple. Let me just show you what I have done in my breadboard. So here is the GP16 pin, that is physical pin number 21. I'm just going to connect anode of the LED to the GP16, and cathode I'm just going to connect it to ground, that is pin number 23. So that's all about the connection. I'm not going to connect any resistor since this is driven via 3.3 volt. For safety reasons, if you want, you can add a 1 kilo ohms resistor or 220 ohms resistor right over here. That shows no impact. That's all about the schematic that I'm going to build. Now I'm just going to dump this flash to my Raspberry Pi Pico development board and visualize the output in the hardware. Now when I click on this particular icon for dumping the flash, you can see my LED, which is connected to GP16, is toggling at a rate of 1 second. That is, for the first second it is on, and for the second it is off. Now when I try to reduce this particular period value to 500, my LED will be toggling at a rate of 500 milliseconds. Now when I dump the flash, you can see the toggling rate is changed to half a second. Now when I try to reduce further by 100, this will be much faster. You can see the LED is toggling at a rate of 100 millisecond. 100 millisecond it is on, and for the next 100 millisecond it is off. So this is the output which I got in the hardware, and I hope you learned how to implement timer interrupt, that is timer periodic interrupts, in Raspberry Pi Pico W in this particular video. See you in the next video. Thanks for watching.